The section that we're going to be reviewing today is about simplifying radicals. Simplifying radicals is not a separate section in the textbook, however, it is a skill that you will need in order to complete some of the activities in the textbook. Remember that a radical is just another word for a square root symbol. So if we're going to simplify the radical, in this case, 36 is a perfect square, and the answer is just 6 with no radical sign. The reason that it is just 6 is because 36 is 6 times 6, and whenever you have two of the same answer, one of them comes out. A square root of 100, the answer is just 10 because the square root of 100 can be broken down into 10 times 10, and these are the two practice problems that you are going to answer. Sometimes the problem does not break up evenly into perfect squares, so we need to simplify this radical. And in order to simplify the radical, we need to find the square root of 8. The way that we do that is we factor 8 into 4 times 2. 4 is a perfect square, so I take the square root of 4 and I get 2. This 2 doesn't have anything to go with it, so therefore it stays underneath the radical and gets brought up to be next to the 2, and the answer therefore is 2 times the square root of 2. You would do the same thing for 98. 98 is a very large number. If you can't remember what a factor is, since it's even, start with 2. 2 goes into 98 49 times. Well, now I recognize that 49 is a perfect square. The answer of the square root of 49 is 7. This 2 does not have anything to partner with, so it just gets moved to be next to the 7, and my answer is 7 times the square root of 2. Sometimes we can have a problem that has a radical with a coefficient. In this case, when there's a radical with a coefficient, the coefficient stays and I simplify the radical. Well, the square root of 18 can be simplified into 9 times 2. This 2 that is right here gets brought over. This 9, I take the square root and it becomes 3. And this 2 right here doesn't have anything with it, so therefore it stays as the square root of 2. 2 times 3 is 6. The square root of 2 remains, and my answer is 6 times the square root of 2. Now it's your turn to answer these two questions. Sometimes we are asked to multiply. In that case, what we do is we rewrite the radical. Instead of 2 radicals, we rewrite it under 1 radical, and this becomes 5 times 3. Well, 5 times 3 is 15, and I cannot simplify that anymore, so my answer is simply the square root of 15. If I have a problem like square root of 5 times the square root of 15, there are 2 ways to approach this problem. One is to multiply 5 times 15, and you get 75. And then you would break down 75 into 25 times 3. Well, 25 is a perfect square, and the perfect square for that is 5, and 3 has no match, so it just becomes 5 times the square root of 3. These, however, if I have 5 times the square root of 15, I can have 5, and then I can break 15 up into 5 times 3. What this allows me to do is it allows me to see that there are 2 square roots of 5 that then get grouped together and brought out, and this 3 doesn't have a match, so 5 times the square root of 3 is also my answer. The advantage to doing it this way is when you are dealing with larger numbers, it's easier to break them down. Some people might not see that 75 is 25 and 3, and they may choose to divide by 5 and get 15 again, which doesn't really help you. So by breaking the numbers up and factoring before you multiply, it's easier to do the problem. Case in point, if I look at this, 2 times the square root of 3 times the square root of 33. There's nothing to simplify here, but I can simplify 33 into 11 and 3. I now see that this is the square root of 3 and the square root of 11. Well, now I have the square root of 3 and this square root of 3 here, which gives me 3. I bring down my original 2, and I am left with the square root of 11. 2 times 3 gives me 6, so my answer is 6 times the square root of 11. If I had multiplied these, I would get 2 times the square root of 99, and now I have to separate this out as 9 and 11, which still gives me 2 times 3, because this is in a square root and this is in a square root. And I'm left with the square root of 11, and I have 6 times the square root of 11. It's a lot bigger numbers, and sometimes people will not see how to break this down. At this point, I would like you to take a moment and practice doing these problems. Now, sometimes we're going to be dividing, and when we divide, we have to rationalize the denominator. That means we need to eliminate the radical in the denominator. In order to eliminate the radical in the denominator, we multiply by whatever the denominator is. So if I have 8 over the square root of 3, I'm going to multiply by the square root of 3, because the square root of 3 times the square root of 3 is just 3. But remember, whatever I do to the bottom, I have to do to the top. So I am left with 8 times the square root of 3 over 3. While it does not look very nice because it doesn't divide away, I'm not going to turn this into a decimal. I'm just going to leave that as my answer. Again, if I look at this example, the square root of 3 over the square root of 5, I'm going to multiply by the denominator, which is the square root of 5. Whatever I do to the bottom, I do to the top. The square root of 3 times the square root of 5 is the square root of 15, and it cannot be simplified. The square root of 5 times the square root of 5 is just 5, so my answer simplifies to the square root of 15 over 5. Here's another example. If I have 12 over the square root of 3, I multiply the bottom by the square root of 3, I multiply the top by the square root of 3. 12 times the square root of 3 is just 12 times the square root of 3. They can't be combined. They just have to sit next to each other. The square root of 3 times the square root of 3 is 3. But now when I look at this, I see that 12 divided by 3 is 4, and the square root of 3 stays, so my answer is 4 times the square root of 3. Here are 2 examples that you should try. Sometimes when we rationalize the denominator, what we are given is not always so nice and pretty. In this case, I have a coefficient with a radical for both problems. When I multiply, I am still only multiplying by the radical on the bottom, not by the coefficient. So I'm going to multiply the square root of 3 and the square root of 3 to the top and the bottom. This gives me 5 times the square root of 15, because I multiply the radicals, but the coefficient stays in the front. 3 times the square root of 3 is 3, and I just bring that 2 over, and then I multiply. So I am left with 5 times the square root of 15 over 6. Again, it doesn't look very neat and tidy, but it is the correct answer. With square root of 6 over the square root of 3, there are two different ways to do it. One is to rewrite the problem so that the 6 and the 3 are under the same radical. This allows me to reduce the fraction of 6 over 3. 6 divided by 3 becomes 2, and the square root sign is there. By reducing beforehand, I have simplified my problem, and I don't need to do any work. This is my final answer. I don't need to do any more work, I should say. The other way to do it, which is the longer way, is to multiply the denominator and the numerator by the square root of 3. That gives me the square root of 18 over 3. The problem here is that the square root of 18 needs to be simplified. I cannot leave it like this in the problem. This factors into 9 and 2, and the square root of 9 is 3 times the square root of 2 over 3. Well, now I have to continue to reduce it because 3 over 3 reduces to 1, and therefore my answer is still the square root of 2, but I have done a lot more work. It is very important when you evaluate problems to see where you can reduce before you multiply. For example, if I look at the square root of 36 over 20, the square root of 36 simplifies to 6. If I were to multiply by the square root of 20 times the square root of 36, I would get a very large number that I would then have to factor. You also want to simplify 20 into 4 and 5. Well, the square root of 4 is 2, and I am left with the square root of 5. In this way, I just have to multiply by the square root of 5 over the square root of 5. 6 times the square root of 5 over 2 times 5. The reason I'm writing it like this is because I was focused on multiplying by my radicals, and I didn't realize that I can reduce 6 and 2. 6 divided by 2 becomes 3. The square root of 5 is there, and I'm just left with the 5 on the bottom. I could have changed this to 6 over 10 and then reduced, but if I can reduce beforehand, it saves me steps. If I look again, what I was saying was, if I try to multiply this by the square root of 20 times the square root of 20 without simplifying, 36 times this 20 is 720. Well, now I have the square root of 720 over 20. This has not been simplified because now I need to go back and simplify the square root of 720, which is a lot more work than if I simplify as I go. These are the last two problems that you are going to be attempting to do on your own. Please make sure to bring any questions that you have to class or any technical difficulties. Please make sure you let me know if you have any questions or concerns or had any problems viewing this video.